Hi everyone, today in Integrated Math 1, we're going to go over Chapter 13, Lesson 5. Here are the objectives. Make sure you write them down in your notes. Alright, so let's go over what a trapezoid is. A trapezoid is a quadrilateral. Well, remember, quadrilateral has a keyword, or I should say prefix, quad in there, which means 4. So we're talking about a polygon with 4 sides. And notice it also says with exactly one pair of parallel sides. So we have them right here. Those little arrows mean parallel. The parallel sides are called bases. So we have a base here and we have our second base here. The non-parallel sides are called legs, which are shown here. And the base angles are formed by the base and one of the legs. So here we have it base angle, and we have the other two up here as well. And then if the legs of the trapezoid are congruent, then if that is true, then we have an isosceles trapezoid. Alright, so let's go over isosceles trapezoids. If a trapezoid is in fact isosceles, then each pair of base angles is congruent. So notice here, angle G and angle H, these two are congruent. And then we also see that angle F and angle J are also congruent. So here we have an isosceles trapezoid because our base angles are congruent to each other. If a trapezoid has one pair of congruent base angles, then it is an isosceles trapezoid. So we're just talking about one pair of them. So angle L and angle M. These two are congruent. Because of that, we know we have an isosceles trapezoid, in our case KLMP. A trapezoid is isosceles if and only if the diagonals are congruent. So we're saying that QS is congruent to RT. And that can also be in the reverse of TR and SQ as well. If this is true, then we have an isosceles trapezoid once again. Notice we have the parallel sides and we have congruent sides as well. So now let's talk about a midsegment of a trapezoid, which is the segment that connects the midpoints of the legs of the trapezoid. So think about if we had this little trapezoid here and we folded it in half. Where would that crease be? Well, the crease would be at the midsegment. So, and this is the theorem that we were just talking about. So, the midsegment of the trapezoid is parallel to each base and its measure is 1/2 the sum of the lengths of the bases. So if side BE is in fact the midsegment of the trapezoid of A, C, D, F, then we could say that AF is parallel to BE and that CD is parallel to BE. But also notice this little formula here. This is going to be key for you guys. That BE is equal to 1/2 of AF plus CD. And there we go.